Hi, my name is Matthew Mullis, and this is my MSE mini project 3 on polymer slimes. So, starting with the slime, when we held it with both hands and pulled it apart very quickly, it deformed very elastically like a solid, and it was pretty brittle. And you can see here in this video that it just kind of snaps apart and has a clear cut, being a brittle and solid-like deformation. Hold on, sorry. So then when it was pulled apart slowly, it deformed a lot more viscously like a liquid, as we can see here as it just kind of pulls apart and it's not fully deforming and it's not like breaking, and so it's like I said, acting more viscously like a liquid. Oh, sorry. And then, so when we held the slime with one hand and let gravity stretch it, we saw that it would slowly deform, and this would be an example of creep, as there was the amount of stress on the slime remained constant throughout this time, but the strain was increasing. We can see here how it's being pulled down. Oh, I'm sorry. And then when the slime was held at a fixed distance apart, the force, it can be a little hard to tell, but my sister confirmed this with me. The force did start to decrease that she needed to have. And this was an example of stress relaxation because the strain was constant with the amount of distance remaining constant, but the amount of stress that was on the slime was decreasing. So now here's our bouncy ball slime, and when it was bounced, it bounced about a foot to 2 feet, somewhere in that range, and it probably would have gone even further higher up had we not made our slime so big, or our bouncy ball so big, but it was a pretty big one, as you'll be able to see that in the video as well as some pictures coming up. So then how was the recipe/procedure changed to get a thicker bouncy ball recipe? And there's kind of two key changes. The first was to the recipe where we added more glue per water, which definitely increased the density of the polymer because that glue is denser, obviously, than the water or the borax, so it made it a more dense polymer. As well, then in the procedure was changed as the glue and borax solutions were mixed immediately and directly with each other instead of having time to both kind of settle on their own and then be mixed together. So then here we put the slime ball next to the bouncy ball, and we see the slime ball being the green one, the bouncy ball being the white one, that over time the green slime spread a lot faster and further. And moving on here, we could say that of the two batches, the bouncy ball has a higher Deborah number, and this is because that when as an object or a polymer's Deborah number increases, it will behave more solid-like, so it will remain in a more constant state and be less viscous and more elastic. And we can see this with how the since the bouncy ball didn't spread out as much, it didn't deform as much, it would have the higher Deborah number. Thank you for watching and have a great day.